Hey there, so I decided to split the example into another video because it might be long. Let's get into it. Being given this example and we're asked to find the solutions for the system of equations using the Gaussian elimination method. So the first thing that I want to do is make all these decimal numbers whole numbers by multiplying them by 100, and that would give me 5x1, 7x2, 6x3, 5x4 equals 23, 7x1, 10x2, x4 equals 31. So now I'm going to put this in an augmented matrix. That'll be 5, 7, 6, 5, 7, 10, 8, 7. First thing I notice is that these two constants are equal, so I want to take this row, equation 4, and subtract equation 1 from it to eliminate x1 in this case. Another thing I'd want to do to also eliminate x1 from the other equations. So I'll do that for the rest too. Take equation 2 and subtract 5 out of 7 e1. That takes equation 1. So this should be 7 out of 5. Because it's supposed to take equation 1 divided by 5 and multiply it by 7. Same thing for equation 3. Multiplied by 6 divided by 5. Okay, let's get into that. So equation 1 stays the same. 5, 7, 6, 5, 23. Equation 2 changes to 7 minus 705. That's 5. Equation 3 Then that becomes 0. This becomes 8 minus 6 over 5. And the answer becomes 33 minus 6 over 5 times 23. 27 over 5. Which is 8. Now I want to multiply these by 5 to get new matrices. 5, 7, 6, 5. That stays the same. Here that is 23. I have 0, 1, minus 16, 0, minus 1. And we have 0. The next step I want to take is use this one to eliminate that value there. Yeah, let's do that. Let's still eliminate this row, so this equation we can add 2 times equation 2. 5, 7, 6, 5, 23, 0, 0, 1, minus 16, now you can see a general pattern here. We have 0 there, 2 zeros here, and now we're trying to get 3 zeros down here. We can take this row, E4, and subtract E3. But we have to divide E3 by 18 and multiply it by 3. Should have added that instead of subtracting it, because this is negative. So can multiply this by 6 throughout. We have 5. Now equations are ready to be used for elimination. So the last row represents 45. X4 equals 73, and that means X4 equals 73 over 45. Second last row represents minus 18 X3 plus 15x4 equals 25. Since we know the value for x4 being 73 over 45, we can substitute that in and solve for x3. Get that value for x3, and we can backward substitute to get equation 2, which is x2 minus 16x3 and it gives us x2 of minus 43 over 27 and x1 using the first equation 5x1 So now we have our x1, x2, x3 and x4. Since initially they were given to us in decimals, and we should leave it as decimals of 2 places. So for x1 we have 709 over 135, which is equal to 5.25. Next 2 we have minus 43 over 27, next 4 we have 73 over 45, which is approximately equal to 1.62. And that's Gaussian method with backward elimination. The trick is to get our matrix in this form where we have 1 0, then 2 zeros, then 3 zeros, 4 zeros, so forth, until we have one constant and one answer, so that we can use the last variable to substitute back into all the other equations and get the answers. Hope this helped. Bye.